So I'm Lloyd Hicks with Hicks Safety Services out of Farmington, Arkansas. We're near Springdale, Fayetteville area. Today we're going to talk about rigging fundamentals. This will be a short section of my 8-hour rigging competent person course. Kind of give you guys some ideas about what we cover in rigging. Kind of give you guys some ideas of things to be looking for at your workplace with what you're doing for rigging. Rigging is a lot of different things. That just includes working with cranes. It also includes working with any other lifting apparatus, such as come-alongs, chain hoists, overhead cranes, forklifts, anything that you're using to lift with. All these things apply. There are several OSHA standards and ANSI standards, ASME standards that apply to all the different organizations or types of work that's going on. There's general industry standards, there's construction standards, mobile crane standards, to be more specific on overhead crane standards for both general industry and construction sites. All the standards that we're going to talk about today are under the B30.26, B30.9 ASME standards, which OSHA incorporates by reference into the OSHA standards. Most of the OSHA inspectors, and just as a good safety practice, will follow those ANSI standards or ASME standards to do a rig. As we work through today, I'm going to try to help you to be able to understand this, be able to understand what's going on with rigging and how to do things with it. A couple of different things we're going to talk about. Working load limit is one of them. Working load limit is the capacity of the rigging gear. A crane is only as strong, a lifting device is only as strong as its weakest link. That weakest link, you could have a 500-ton crane with a 2-ton shackle. All that crane can pick up is 2 tons. B30.9 is talking about slings. Slings, as we're talking about slings today, I'm going to cover some of the inspection processes and different types of slings. And again, I'm just kind of going off the hip on a lot of this stuff, but I'm going to talk about inspection of slings right quick when I'm talking about it. This is probably a round sling. These are very common, very popular, very versatile, used in a lot of different ways. And so what this one is this is like a 3-foot endless. It's got a working load limit of 2,000 pounds. So one of the first things before you ever use any type of rigging gear or rigging equipment, you want to inspect it. To inspect it, I like to start at the tag. That's the first thing you need to look for. Make sure you've got a tag on it that you can read and see the tag. If the tag's in good shape, then you can start inspecting. With this particular type of sling, you want to look for any kind of damage to the outer layer, any kind of weld burns, where it's got to get something hot, melted, or charred. Any of those things. Then you want to feel inside of this, there's lots of fibers inside of this, endless fibers. They just make big circles. So you want to make sure that there's no knots in that fiber. If this sling had been overloaded, you would be able to see some of those fibers. They would knot up and they would bunch up in place in wherever that place is. I've actually got one here that we've taken out of service on a project. You can kind of see the insides of it as to what it looks like. This one was damaged, so we destroyed it to be able to use it for training. And that's what it looks like on the inside. These are the endless type wire rope slings. Got one here. This is an example of a wire rope sling. It's got a couple of different types of end attachments on it or end pieces on it. But the main thing with this one, you again want to look for the tag. Make sure you've got the capacity on it, manufacturer's name, capacity, and look for broken wires. You have 10 randomly broken wires in one rope blade, or 5 strands in one rope blade, 5 wires in one strand in one rope blade. Then you want to take this out of service. Personally, if you start getting a lot of broken wires in your wire ropes, it's time to take it out of service and figure out what's going on and why it's doing it. Either the choker or the sling's been used a lot, it's worn, the fibers get weak, or you're damaging it in the way that you're using the lifting gear, lifting equipment. Here's just a plain old nylon sling. Again, we'll look to make sure you got a good tag on it. It says how much it's got, what kind of capacity it's good for. Check the end eyes real good. And looking for any kind of cuts, snags, tears. Look at the stitching. Make sure the stitching's not worn or torn. Somewhere. Okay, but something too that I've seen in the past, and I'm not sure that a lot of folks know about this, but you may have seen some folks before put the eye of a choker over a fork on a forklift. You slide the fork in like this, right? When you load that choker, you're putting a lot of stress on this joint, this connection. Okay? The ANSI standards actually say, or SME standards actually say that you cannot load more than 50% of the eye. So you've got to consider what you're using, how you're using it. Is that the right thing? It is actually against the OSHA rules and regulations to put the sling over the fork of the choker. You don't have positive load control. If somebody tilts, it can slide off the end of the fork. Again, it can damage it. There's a couple of different options that you can use. You can actually buy add-ons to the forklift that give it below the forklifting device. Some of the newer forklifts actually have a hook or a shackle connection point behind the main backrest, and with that, you can hook this up behind it. Just make sure that whatever you do, if you're using a forklift and you're adding on the appliances to that forklift, that you have approval of the manufacturer to do that. That it is approved by the manufacturer, you can do that. Make sure you check your capacities on when you do that. Getting into a little bit of hardware, rigging hardware, some things with rigging hardware that would be included are shackles, hooks, cable clamps, collector rings, all kinds of good stuff. With a shackle, one of the main things you want to look for is manufacturer's name. And you may see Crosby on a lot of this equipment. Crosby, several years back, I took a Crosby instructor course and purchased this equipment. I'm not a Crosby salesperson. I do believe in Crosby, so that's one of the reasons I use them. But looking for the name, manufacturer's name or trademark, the working load limit, what that capacity is on it, and then the size of it. All of those should be able to be read, be legible. The ASME standards say that you must be able to read the name, trademark, and/or trademark of the manufacturer, the size and capacity to be able to use it. So you want to make sure you can inspect it before you do that. And then another part of your inspection is make sure you don't have any wear. You can have up to 10% of the catalog dimension of wear in your shackle. Okay, and all in some of the main points. Okay. This particular shackle was taken out of service because of the wear on this pin. I don't know if you can see it or not. There's a flat spot on this pin that occurred over time, and that's enough to take this particular shackle out of service. Another thing you want to look for is complete pin engagement. Pin engagement means the shoulder is in contact with the shackle on this side, and all the threads are used on this side. I'm going to simulate this by backing it out a little bit. If that's as tight as it goes, you don't have complete pin engagement on the shoulder. This would allow this shackle to expand in and out, which eventually would cause damage enough to cause it to be removed from service. Another item is incomplete pin engagement, and that's if the pin doesn't screw all the way in. If it doesn't screw all the way in, that means it's got extra threads out here. You're putting extra load on this pin that it's not designed for. So it's time to take it out of service. One other good point that I need to make about hardware, rigging hardware especially, look for the name. Doesn't have a name, look for a trademark. Doesn't have a name or trademark, look for a country of origin. The country of origin that you don't want to see is, drum roll, China, right? Because China has sent a lot of stuff over here that is inferior products that are not they do not meet the standards of U.S. standards. They're made from metal that's too soft, that it doesn't do what it's supposed to do. The metal that hardware is made from is supposed to be have ductility and be able to stretch and expand without failure. Here's an example of stretching and expanding without failure. This hook was overloaded. This is a 2-ton hook. This was part of the testing process for Crosby. This is a 2-ton hook. It actually failed at a little over 20,000 pounds. Okay, and if you notice, it may not have even failed catastrophically because a sling might have still been attached to it. But if you're overloading something to this point, you should hear it popping and cracking and making sounds. You should be able to see and hear the safety latch release. If you don't see that, or if you do see that, you know you've got a problem because you've expanded, you've opened the throat up on the hook. Another big thing about the hook is you want to make sure that it does have the safety latch on it. Here's an example of the safety latch, and that it engages where it's supposed to be engaged. If it engages in a different point besides at the tip of the hook, like down into this area, then there's a good chance that this safety latch has been replaced with an inferior product or product that's not recommended by the manufacturer. Anytime you repair any piece of equipment, you have to repair it back to the manufacturer's specifications. And to do so, you have to know what those specifications are. So that's one of the things you need to make sure you pay attention to, is watching out for that. When you're inspecting your rigging gear, one of the things, or some of the things you look for with your rigging hardware, same thing, evidence of heat damage, any kind of pitting or corrosion, weld spots, weld arc strikes, cracks, nicks, gouges, any kind of rough edges or areas. And if you've got a burr or a rough edge on your hook or your shackle, then there's a good chance that you're going to damage your choker, especially if you're using a nylon or even a poly or even a wire rope. If you've got an edge on it that's grabbing it, you can actually cut it and damage it. While I got this sling in my hand, I just remember one thing too to consider about slings. Keep your slings clean. It really bothers me a lot, especially when I see slings laying in the sand or in the dirt, in the mud, and the gravel, and being driven across. When you get dirt into this choker, synthetic wire rope, it doesn't matter. If dirt gets into this material, as it works inside of this material, it's working just like sandpaper. And it's actually cutting the fibers, damaging the fibers, going to reduce the capacity, it's going to reduce the useful life of your sling. So you should always make sure that you keep your slings out of the mud, preferably out of the sun. Keep them dry, if at all possible, or at least store them in a dry place. The bed of your pickup is not the place to store your chokers. Okay? Neither is the place to store your harnesses too. Somebody else is covering fall protection for that. When you're looking at your hooks, again, you want to make sure that you don't have wear no more than 10% in any of the normal areas, no more than 5% in the top, and then the throat area. Okay. Another thing that you want to look for is the throat opening. Again, not a Crosby salesperson, but Crosby has what they call quick check marks on their rigging gear, on the hooks. You can actually measure between these two marks right here. Go to the Crosby catalog and it'll tell you what that measurement should be. It should have no more than 10% of opening or more than 5% of twist in the hook. Anytime you have any condition that you have warrants to consider not using it, just don't use it. It's simple enough. Go back and get it. Go back, take it to your manufacturer, distributor, have them send it back to the manufacturer and recertify it. If it is recertifiable, trash. They want to see how it works and why it's done that way. A couple of things, collector rings. This is an example of a collector ring. Again, name, manufacturer, trademark, capacity. And these actually have angle indicators on them with a 45-degree angle. You can actually load these depending on the size and the shape of it and the manufacturer's recommendations. You can load these beyond 45 degrees in some situations. Check with your manufacturer on that. Swivel hoist rings. These are pretty handy to have, especially if you're lifting and moving panels, and especially if you're doing a lot of picking stuff up, laying it down. This swivels with it. One of the things you got to be careful about is these do have a torque rating on them, and this big, heavy swivel hoist ring is only good for 2,500 pounds. So you may have to end up having multiples or doing something different, a lot larger piece of equipment. So that's something to think about as well. One thing about another thing about hardware and slings, you want to try to match your hardware to the type of sling you have. This is an eye-to-eye sling with two flat eyes on it. This is actually a shackle that's designed to work with this sling itself, so it keeps it good and flat. It spreads the load off over the entire sling, so that it spreads the load out real good. If you don't have the right kind of gear, you can get what's called bunching and pinching. This is an example of bunching and pinching. When you load this up with this choker, the way that it goes in it, the longer radius is going to carry more load, gives you the option of damaging your equipment. There's a couple of different types of eyes. This is eye to eye. There's a twist eye. I got a twisted eye on here. It's damaged. This is a twist eye. If you notice when you put it in the hook, it loads it better. And then there's a difference. You don't have a twisted eye. This is a twisted eye. That kind of helps you. Getting your rigging gear, getting the right kind of rigging gear is very important. Making sure that you're using it in the way that it's designed, that you don't exceed the weight capacity on it. Know what the load is. If you don't know what the load is, then you've got to find it out before you can designate your rigging gear. Here's another example of this is a swivel hoist. This could be added to a shackle or it could be added to the end of a wire rope choker. This is a positive lock. When you load this hook, it locks. There's no gate on this one. You have to push a button on the back to open it up. These become a little bit more common, a little more popular because of the fact that it has a solid gate on it, doesn't damage as easily. So that's some examples. Some of you guys that do trench and excavation, those kind of things, a lot of times they'll have a hook welded on the bucket of your track coat. This is a weld-on hook. Okay? I don't recommend weld-on hooks. I don't recommend welded hooks. Number one, it has to be designed to be welded. Here's an example of one that's designed to be welded. This is an example of one that's not designed to be welded. When you weld this hook, you have specific heat requirements, types of rods, material that you're welding to, all that kind of good stuff. When you're speccing out your buckets for your excavators, you can actually get a bucket that has the pad built into it that you can shackle up to, or you can hook into while you're moving and maneuvering. The best thing is the quick attach buckets that come out nowadays. You can just detach from the bucket, get your lifting rig, and use that to lift your equipment. That's the best thing. Because I have seen one of these hooks cut with a torch and welded to the bucket. And it was pretty, but it had no capacity because it had been welded. Okay? Anytime you got any weld marks on it, it is trash. Another thing that happens a lot are these are called below the hook lifting devices. Anything kind of sounds pretty silly. Anything below the hook needs to be rated as well. This could be attached to a piece of equipment. This actually was attached to a motor control center, an electric box that had a switchgear in it. This was attached to it and 4 Hicks, and this is rated. It was rated and marked on the box that it was attached to. Once you remove this, there's no rating on it. It has to be engineer approved, engineer rated, so that you know what the capacities are and how it works. I know most of the companies that come to these events are very safe, and nobody would ever do anything strange like this. But I have seen in the past, especially with excavators, where they'll take a piece of pipe and they'll stick the wire rope choker or the synthetic through the hole at the top of the pipe, and then maybe put a rock bar or a pry bar or a piece of pipe inside the hole to make a pitch with. That is not a legal way to do that. Okay? They make devices that go inside of there. They make pipe lifting devices. They make equipment. If you're going to do something like that, you need to get an engineer to approve that lifting plan and lifting device. And you don't want to get into trouble with that. And typically, when you get into trouble with that, it's when somebody gets hurt or killed. So you definitely don't want to get into that. When is a competent rigger required? Competent rigger is required anytime anyone is working within the fall zone of the load. So pretty much in my opinion of that, it's every time you make a pick. The reason is because the rigger has got to be there connecting the hook, connecting the load to the lifting device, whatever it may be, before the lift is made. Another qualified person that's required for construction is a qualified signal person. And there are certain requirements for that as well. So look into the standards for that to make sure you're qualified for that and you've got the right certifications for any time you're doing that. Another thing I want to talk on real quickly is angle of the chokers, sling angle indicator or sling angle. And what that means is this is the angle of the choke. Okay? This one in particular right here is a 45, give or take. I can scoot it closer and make it better and make it into a 60. I can scoot it farther out and make it into less than 45. But either way, this is called the rigging triangle. Either way you do this, all these angles always add up to 180 degrees. Okay? So if you've got 45 and 45, up here you've got 90. 45 on each leg. And in the case of a 45-degree sling angle, this sling leg will see 1.4 times the amount of load that it would see if it was a straight up vertical lift. Okay? So as you go down below 60 degrees, you have to factor in the sling angle factor. From 60 degrees, you go to 1.2 times the load. At 45 degrees, you go to 1.4 times the load. And at 30 degrees, you go to 2 times the load. Okay? Any angles, sling angle below 30 degrees is not recommended because of the amount of force that applies to the choker. But as you go down with your sling angle, there's more force that's being applied to the choker, to the sling, and it's also trying to crush the load. You got to make sure that your load is strong enough to stand the low angles, as well as your choker, your sling, is able to withstand that as well. So I'm going to use this one as an example here. Okay, as your sling angle increases, the load on the hook will increase because it's trying to open this hook up. So if you go beyond 45 degrees off the bottom, you can't use a hook. You have to use a shackle. You go greater than 45 degrees, or the collector ring to go below 45 degrees, like this. Okay. As you go down, there's more force being applied. If this particular piece of pipe here, let's just say it weighs 20,000 pounds for ease of math. Okay. If these legs were both vertical in each side, and the big points are equally spaced, then each leg would receive 10,000 pounds of load. Okay. As you drop that load down, or the angle down to 60 degrees, then that's 1.2. So now instead of 10,000 pounds, it's 12,000 pounds. The force is being applied to the sling, to the hook, to the sling, to the shackle, and to the eyeball. These are all seeing that load. Okay. As you go down to 45 degrees, it goes up to 1.4 angle factor. So again, the hook, the sling, the shackle, and the eye bolt are now seeing 14,000 pounds versus 10,000 pounds of load. If you go all the way down to 30 degrees, that 30-degree sling angle will give you twice the amount. So each leg is getting 20,000 pounds of force applied to it. You got to make sure, in this particular case, this 20,000 pound lift is going to be applying 20,000 pounds of load to each leg into the shackle that would be here because we're less than greater than 45 degrees. One thing that doesn't transmit the lifting device. This is still 20,000 pounds. But that's the amount of force that's being applied to each sling leg. A lot of folks don't factor in that sling angle into their load capacities, and that can get you in trouble, cause damages to your sling, and eventually cause catastrophic failure, or it could cause damage to your load as well. So that's just something to think about. I haven't talked at all about chains. You mentioned that about chains too. Chain slings, I've got a tag on them as well. There's an example of the tag that goes with that. You need to make sure that you inspect it. One of the things, a disadvantage to a chain sling, in my opinion, is that you have to inspect every link before you use that chain. And you don't know if you've got a link that's broken or distorted or not working the way it should. So you've got to really look that sling over really good, as you should all of them. But to me, just the chain slings is a little bit more difficult to inspect. All these have different purposes. They all have different advantages or different disadvantages to where you're working at, how you're working with them. So it just depends on where you're working at as to what kind of sling you want to use. Again, this is kind of a condensed version of rigging. I don't even want to call it a 101 class because this is really just to pique your interest, and hopefully you'll find an instructor, find a qualified person to speak about rigging. One of the slides in my full presentation says I've done it that way for 20 years. And not meaning any disrespect, but did you do it the right way for the last 20 years? And I get that a lot. I get that a lot with experienced folks. They say, we've done it this way for 20 years, never had any issue with it. One of the first things that people always talk about, always bring up to them, with a shackle. People who use shackles on a regular basis, you're supposed to fully engage the pin. That means it's tight. Not wrench tight, not twisted tight. Just touch it. Engage. Okay? Not engaged and backed up a quarter turn. When you back it up a quarter turn, it's not engaged. So you need to open it up. No. You need to keep it tight. You keep it tight. If you back it off a quarter turn this time, and you back it off a quarter turn next time, and eventually, even while you're making a pick, you could actually unscrew the pin. You need to make sure that you keep it engaged so that it doesn't unscrew, also so that it doesn't damage your shackle. If it's not fully engaged, then it can allow this shackle to spread, like I said earlier, cause damage to your shackle. The ductility of the shackle will be diminished, and the shackle is designed, when you load it, to spread down and out. It's not designed to spread at the top. Okay? So, and as the saying goes, if it don't stretch, if it don't bend, it breaks, right? So you want it to bend a little bit, you just don't want it to break. And to keep it from breaking, the main thing you need to do is not overload it. Here's an example of a shackle that was overloaded, again, in testing, and that's where it failed, at the threads of the pin. Okay? So that's just an example. This shackle is, again, a 2-ton shackle, and this failed at 26,000 pounds. That was a direct, inline, steady pull. Anytime you shock load or dynamic load your rigging gear, it adds to those loads, adds to the shock, adds to the possibility of damage. What is dynamic loading? I'll use my joker here with an attachment on it. That's an example of dynamic loading. Dropping it down, jerking it, that would be dynamic loading. Okay? Swinging from side to side is also a different type of loading. It can be dynamic loading. Anytime you get the load out from under the hook of the of the electric device can cause damage to a lot of different things. So those are some things to consider. I think that's about, we get on cable clamps right quick. Make sure that your cable clamps are rated, company name, signal, size, and torque value. These all have torque value. Just as an example, this is a large cable clamp. It's made for 5/8 cable. Does not have a torque value, and it's made in China. This is not designed to be used in any critical application. These can be used in critical applications such as guiding, creating fall protection, horizontal lifelines, vertical lifelines, whatever you may need. These can be used for that. I think I'm done for the day. This is my time is up. I just want to again thank you guys for clicking on it. Thank you guys for looking at our presentation. Again, my company is Hicks Safety Services, Lloyd Hicks. You can search us out on the web, hickssafetyservices.com. We're located in Farmington, Arkansas. We will travel to wherever we need to go to do the work we need to do. If you got any questions, feel free to contact us through our website. Call me, text me, email, and we'll be glad to answer any questions you may have. Schedule for training, whatever you may need. I'll be glad to help you wherever we can. Thank you very much.